I'm now recording this session. Before I start working on number one, a couple of important things to let you know about. Number one, right after this class, starting 10 o'clock, there's a new quiz posted on Delta Math. It's on chapter 6 and 7. That means on the radicals, the i's, and the quadratic equations. So that's on Delta Math quiz number 4. I'm giving you until the end of the term. The last day of the term, the last class, is December 14th. So that's my other thing that I want to let you know about. First of all, next Friday, which everybody knows is Black Friday, there is no class here. I think the school itself, I hope Medgar itself is closed, but we're not going to have class next Friday. After today, there are only 10 more classes left, and we still have to finish 2.5 chapters. So we have to be pretty efficient about this. So make sure you keep up with the work. As of this point, I have given you the midterm, plus there are now going to be 4 tests on Delta Math, and there was the pre-test, the pre-midterm, which was on Blackboard, and of course the midterm on Blackboard. So as I count as class quizzes or class tested, the 4 Delta Math quizzes and the pre-test, that means there are 5. There probably will be 1 additional to that, which will be, there'll be a total of 6 class quizzes, of which I will pick the 4 best marks as your average for your class. Your class average will be based on those 4 marks, plus your extra credits, plus your homework. All that counts in as class marks, in addition to the midterm and the final. If you have anything that you want to make up or you want to do better on, let's say you weren't so happy with your mark on the midterm, if it was not a passing mark, I'm not changing mark, I'm not giving anybody a chance to do the midterm because they got an 80 and they really wanted an 85. That doesn't sort of make sense. But I will give you somebody who has failed the midterm an opportunity to retake it if they let me know that they want to do that. I don't think it applies to anybody who's in attendance right now. So those are my announcements for today. No class next Friday. Last class of the term is December 14th. And there is a new quiz posted on Delta Math. So first, let's find the vertex of this parabola y equals x squared minus 6x minus 5. And what I told you you have to know is a formula that says x equals negative b over 2a, where the a is the number that's in front of the x squared, which if there's no number, we understand it to be 1. The b is the number in front of the x, which is negative 6. The c is the number that stands alone without any x, the constant. So if we're using this formula, x equals negative b over 2a, we're going to have to do negative 6 over 2 times 1, which will give me a positive 6. 2 negatives gives me a positive over 2, which gives me 3. Which means right away, no, it's either going to be choice B or C. It did not come out to be negative 3. Notice how close the answers are. But in order to figure out what the other value is, we have to figure out the y value by substituting in this value of x. This is the value of x on the vertex. We'll find the value of y by substituting the 3 in for the x. That'll give us 3 squared minus 6 times 3 minus 5, which is 3 squared is 9 minus 18 minus 5. And if you could stick this into your calculator, or you could do it in your head, but be careful with your sign. 9 minus 18 is -9. -9 and -5 is -14. So the correct answer, I think the people who sent me the answers all picked choice C, which is the correct choice. Okay, this problem actually came straight off a final exam here in Med Grammars. So this is something that you have to know how to do, how to find the vertex. We're going to come back to these type of questions after we finish going over question number 2. Now, this question happens to be something that we're doing chapter 9 now. This is from chapter 9. We skipped chapter 8. We finished quadratic equations was chapter 7. That's what question 2 is about. We're skipping for the meantime chapter 8. We will be coming back to it. It will be the last chapter we're going to be discussing. But right, so we skipped it and we're going on to chapter 9. This question came from chapter 9. All right, let's look at this one. I told you before that it's not a quadratic equation that can be solved by factoring. It can't be broken up because I can't think of any numbers that multiply to 41 and when I add them give me 8. There's just no combination that works. So the only way to solve this, again, it's a quadratic equation because it has that y squared. The only way we can solve this is by using one of the other 2 methods. One is the completing square method, one is the formula method. Well, I'm going to use the formula method on this, and then I'm going to go back and I'm going to do completing the square, and I'm going to let you decide which method you would have liked better for this particular problem, keeping in mind the completing the square method is not a good choice in all cases. It's a good choice here because the leading coefficient, the A, is 1, and the B, the number in front of the Y, is even. That's the only time it really makes sense to try the completing the square. You could do it in other cases, but it would run into very difficult fractional computations. So if you can't use factoring or the completing the square, you have to go to the formula. But the formula could be used all the time. So it's a good idea to practice that formula. Now, whenever I want to use a formula, and notice I left it on the board. It's so important. The 2 formulas that you must know are the quadratic formula and this formula now that we talked about for the vertex of a parabola. We also have to know the formula for trying to think, what other formulas did we do this year? We had some other formulas that we used. I will be posting shortly, I think probably right after the Thanksgiving holiday, a review sheet or a review. It's not just a sheet, it's several sheets. A study guide for you to use to study for your final exam on. Instead of having to go through the whole book again, you'll have all the basic formulas and types of examples that you'll see on the final. So I'm going to be posting that probably on the information section of our Blackboard account. I'll let you know when it gets posted. And it will include all the important formulas that you need to know for this course. Okay. So going back to this, we're going to be using the formula. So we have to write out what is the A, what is the B, and what is the C. And the A, of course, here is 1. The B is 8. And the C is 41. We're lucky all these numbers are positive. It's always easier to deal with numbers that are positive. So sticking the numbers into that formula, it's going to be, here's our negative, here's our B. Remember, I put a parentheses where one of those letters are, and I fill it in with the specific number, including its sign if it has a sign. If it has a negative sign, make sure to include it. Then it's, so this is going to be negative parentheses 8 plus or minus. Okay, now this is B squared. So in place of the B, we're putting 8 minus 4. The next number is A, which I'm putting in a 1. And the next number is C, so I'm putting in 41. And all of this is over 2 times 1. So we've now substituted all the numbers into the formula. Now we have to simplify what we have. So this just becomes negative 8. Now here's where we're going to have to be careful. 8 squared is 64. And 4 times 1 times 41 is minus 164. Of course, you could do this on your calculator individually. 8 squared is 64. 4 times 1 times 41 is 164. So this becomes 164 minus 164, which gives us negative 100. Be careful that with that sign. 64 minus 164, the 164 is negative and larger, so I'm getting a negative 100 all over 2 times 1, which is 2. And remember, the next important step is to simplify the radical. So if I go over here, let's just do it over here. I have the square root of negative 100. Which really is the square root of 100 times the square root of negative 1. And the square root of 100 is 10. And the square root of negative 1 is I. Don't forget, the square root of negative 1 is that special number I. So this is turning out to be negative 8 plus or minus 10I divided by 2. And if you recall what we did, we separate this as negative 8 over 2 plus or minus 10I over 2. And these can be reduced to negative 4 plus or minus 5I. And as long as you're careful with the numbers, it works out. It turns out that the answer you got was an answer that had I, where the answer is in what we call A plus BI form. It's a complex number that sometimes happens when you solve a quadratic equation. Sometimes you get just regular rational numbers, whole numbers or fractions. Sometimes you get answers with square roots in them, radicals. And sometimes you get numbers with I's in them. And all that's possible, but you can do it using your quadratic formula. Okay, now I'm going to erase this top one. I want to redo this problem using the alternative method of completing the square. It's a good idea to have practice with completing the square. And also, I want you to see which method you would have liked better. It doesn't matter what it says. If it's a question on a final and it said, use the completing the square method, and it just gives you the answers, nobody's going to tell you that you can't use the formula. you can use the formula. I am not going to look and see if you use the specific method that was asked. I prefer a question in which it gives you just a quadratic equation and says solve it, because I think it's more important for you to figure out what method works best for you. Given that, let's look at this equation again. We have y squared plus 8y plus 41 equals 0. Now remember, you're not going to do it both ways. You're either going to do it this way or this way, unless you want to do it two different ways so you can check your answers. You should come out with the exact same answer. Okay, so if we're completing the square, the first thing we want to do is just have the variables on the left side, and any constant number, any number without a x or a y or whatever my variable is, has to come to the other side. So this is going to be y squared plus 8y, remember you leave a space, equals negative 41. And what we're going to want to do is we're going to want to add some number over here to make it into this binomial, add a third number into a trinomial that really is a perfect square binomial. Now, I even know what the binomial is going to be. Why? Because the first term is for sure going to have to be y. And the second term is going to be half the numbers in front of the y, so it's going to have to be plus 4. And the number that we're missing here would be this 4 times 4, which is plus 16. In other words, if I may add 16 to this y squared plus 8y, makes it a perfect square binomial. It makes you into the 4y plus 4 squared. You could, if you're not sure, you want to make sure, just do y plus 4 times y plus 4. You'll see you'll get y squared plus 8y plus 16. Of course, whatever you add to one side of the equation, you've got to add the same thing to the other side of the equation in order to maintain the balance of your equation. Your equation was balanced. Now you added something to one side, you better add something to the other side in order to maintain that balance. So what are we getting now? We're getting negative 41 plus 16, which is negative 25. And now we take the square root of both sides. The square root of something squared is just whatever that is. In other words, y plus 4. On the other side, we're getting plus or minus the square root of this number negative 25. Remember, you're always going to have two answers. One's going to be a positive answer, one's going to be a negative answer. Well, that means that the y plus 4 equals plus or minus, well, the square root of negative 25 is 25 and negative 1, which is 5i. And if you recall, the way I told you to finish it is you want to get the y alone, so you want to get rid of this 4. So you're going to subtract 4 from both sides. And what we said is the number that we add or subtract to get it to the other side, we always put that first. So the negative 4 is going to be first, and then it's going to be plus or minus 5i, which actually is the same answer that we got over there. It should be. And which method do you like better? It's really a matter of opinion. Some people would like the formula because they always can do everything by the formula. Sometimes just people like this, completing the square method. Okay. Going on from here, let's go back to what we were talking about. Let's go back to our parabola. We're going to, and what we're really talking about in chapter 9 are what we call, I'm going to erase this now, the graphs of quadratic equations. The beginning of the term, when we did graphing, we graphed what we called linear equations. And the name very much told us what it was. Linear meaning lines. And we knew that it was a linear equation because it only had a plane x and a plane y. There was no x squared, there was no y squared, there was nothing, no exponents at all. Just x alone, which means x to the first power, and just y alone, y to the first power. So sometimes a linear equation is called a first degree equation. The highest exponent you see is 1. And the only type of a graph you can get from a linear equation is a line. So now we're going to graphs of quadratic equations. That's what chapter 9 is about. And we actually started one already where we talked about the graph of a parabola. And if we look at a parabola, so it's going to turn out that there are 4, with linear equations, there's only one shape, a straight line. Sometimes the line goes up and down, sometimes it goes across, most times it goes at a slant, but it's a straight line. When it comes to quadratic equations, well, quadratic equations are more complicated than regular linear equations. Their graphs become more complicated. We're going to see there are going to be 4 different types of pictures, 4 different types of graphs. The first one we already mentioned is a parabola. And we even mention what the parabola is going to look like. It's basically a U shape. Sometimes it opens up, sometimes it opens down, but it's a U shape. And the point where it's turning around, if it started going down, and here it turns around, or it was going up first and it turns around to go down. Sometimes it's called the turning point. It's called the vertex. And if you'd ask me what's the most important point that you would want to find in a parabola, that answer is it's a vertex. And we even talked about how to find the vertex. Here, let's put that formula on the board. It's x equals negative b over 2a. We used it before, and we said that only gives us the x value of the vertex, but we also have to find the y value because the vertex is a point, and a point has an x and a y value. That point we find by sticking the equation, the x back into the equation. What does the equation look like? Well, the equation is going to look like y equals something like this: ax squared plus bx plus c. It's going to look like a quadratic equation, except instead of having a 0 in it, it's going to have a y. Now, it could conceivably, I don't think you have to know this, start with x and then have ay squared plus by plus c. In other words, the x could be without any exponent, but the y would, which would then give you a parabola also, but it would be a sideways parabola. Excuse me. Hello. Hi, I'm in the middle of teaching. I'm sorry. Yeah, you probably know the timing is a little bit difficult. Have a great Shabbos. Where are you? Oh, okay, didn't do it. Okay, you got that. Sorry. All right. But most often, the type of, we're going to talk about these parabolas that are either opening up or opening down. They're used either up or down. We're not going to talk about sideways. This type of equation, if you notice, it has an x squared, but it does not have a y squared. Only one of the variables has an x squared. Notice there's an x squared and an x also, but when we talk about the degree, we always mean the highest exponent. So in this case, the highest exponent on the x is going to be 2, but the highest exponent on the y is going to be 1. If we have that situation, we have a parabola. And as I said, the most important thing about the parabola is to find its vertex. Now you have to have it in this setup. Y equals something times x squared plus something times x plus c. If it's not set up that way, you've got them, sometimes you have to move around, sometimes you have to transpose some of the terms. So let's do one more example that involves a parabola, and then we can say that we understood what the parabola looks like. So as I gave you this, y equals negative x squared plus 4x minus 3. Now I know this is a parabola. How do I know? Well, it has a y, but no y squared. It has an x squared. So that must make it a parabola. Now, if you recall from what we were saying last night, last time, I'm sorry, not last night, on Wednesday, we can tell whether this parabola is going to open up or down based on the value of A. Let's look and see if we can figure out what the A, the B, and the C is. And the A is the number that's in front of the x squared, and that's -1. The B is the number in front of the x, which is 4. And the C is a number that has no x attached to it, which is -3. It turns out that this looks like a smile, and this looks like a frown. When A is positive, in other words, A is greater than 0. Positive means it's a number that's to the right of 0. You're going to have an opening up parabola. When A is negative, in other words, if A is less than 0, a number to the left of the 0, then you're going to have an opening down parabola. So since our A is negative, we know our parabola is going to be opening down. So that's a very important thing to know. We have a basic idea of what this parabola is going to look like. Now, there are basically three things that we can do. We can find the vertex. We did that as a homework, as an example just now. We can try finding the x-intercepts. We can try finding the y-intercepts. The first thing we always want to do is try to find the vertex, unless the question is something else. If it says find the x-intercepts, or it says find the y-intercepts, and it doesn't say find the vertex, then you don't have to do it. But if you want to do a sketch, if you want to see, and on what they'll give you on the final in these type of problems, they won't ask you to sketch it, but they'll give you examples of sketches, and you have to pick the right one. Okay. The best thing to do with a parabola is first work on finding the vertex. Well, we know that the vertex we get by doing x equals negative b over 2a. And if I stick in those numbers, it's going to be negative 4, because negative b is 4, so it's negative 4, over 2 times negative 1. So that gives me negative 4 over negative 2, which gives me 2. And that, the start of the vertex, to find the y value of the vertex, we're going to go to our original equation, and wherever we see the x, we're going to put in 2. So it's going to be negative. Remember, we put in here's our parentheses that we're filling in, 2 squared plus 4 times 2 minus 3. Now be careful here. The 2 is being squared and then put a minus in front of it. So 2 squared is 4. So this is negative 4. 2 times 4 is 8 minus 3. So negative 4 plus 8 is 4. 4 minus 3 is 1. The vertex of this parabola is 2, 1. Well, what I do then is I go to sketching. Sometimes this is enough. I don't have to know more. 2 to the right, 1 up. Make sure that you have the right vertex and the right signs. Now this is going to open down. How do I know? Because the A we said was negative. So this is going to be an opening down parabola. So sometimes this is enough to know what the parabola will look like. If you have to pick from a bunch of different examples, you want to look at one that has the correct vertex and the correct opening position. Is it opening down? Is it opening up? There are 2 other things we could find. We could find the x-intercepts and the y-intercepts. And I'm going to find the y-intercept first because it's really usually quite easy. To find, and this is a general method, to find the y-intercept of any graph, you take your equation and put an x equal to 0. Wherever you have your equation, you're going to, you look at your equation, wherever you have an x, you're going to put a 0 there. Well, if I look at my equation, let's look at it. This is negative x squared. Remember, x is 0. 0 squared is 0. So that's 0. Plus 4 times 0. That's 0. The only thing I'm left with is negative 3. In other words, the C actually is the y-intercept. So in any case, it's always easy to find the y-intercept of a parabola. If you look at it, it's right here. 1, 2, 3. I actually got it pretty close. Notice if a couple of them had the same vertex, you might look at the y-intercept and see if you've got the one with the right y-intercept. Okay, now I'm going to erase this because we already did it, because I want to do something else. The other thing we could do is find the x-intercepts. By plotting my vertex and my y-intercept, I saw that the parabola is actually crossing the x-axis at 2 points. let's see if we can find those 2 points. It turns out to find the x-intercepts, what you're going to do is you're going to put y equal to 0 in your equation. So to find a y-intercept, you put in x equals 0. To find x-intercept, you put y equal to 0. I'm going to say this a few times over because we'll do this on a number of different examples. So we're going to get 0 equals negative x squared plus 4x minus 3. So in place of the y, I'm now putting 0. And what I'm getting is I have to solve a quadratic equation. I have to solve an equation that has an x squared in it. Now, I really do not like starting a quadratic equation with a negative. But I can, since this is equal to 0, I can bring everything to the left side of the equation. I'll add plus x squared minus 4x and plus 3 to both sides. And that'll give me, over here, this will all cancel out, so that'll give me 0. And my new equation will look like x squared minus 4x plus 3, which is really an easier equation to solve because it's, if we want to factor it, and I see this is going to be factorable. It's easy to factor something that starts with x squared because you just break it up into x and x. Also, you then look at your numbers. The final sign, you didn't look at your signs, your final sign is positive. So that means both numbers are going to have the same sign. And I look at the middle, they're both going to have to be negative. And two numbers that multiply to 3 and add to 4 is obviously 3 and 1. Actually, negative 3 and negative 1 add to negative 4. So we said each of these equal to 0. So we're getting negative x minus 3 equals 0, which gives us x equals 3. And x minus 1 equals 0. Bring the 1 over to the other side, gives us x equal to 1. In other words, the x-intercepts are 3, 0, and 1, 0. And if you notice, I actually think I got pretty close to this because here's here's 1, 0, and here's 3, 0. And now we have a very good picture. So not only can we find the vertex is the most important thing to find, but not only can you find the vertex, you can also find the x and y intercepts. Okay. Okay. I'm going to give you a problem to try. Before we go on to the next one. Suppose I gave you this example. Y equals x squared minus 10x plus 9. And I want you to find the vertex and the x and y intercepts. The vertex and the intercepts. Well, I'm taking attendance and I'll probably just look at the the participant list and use that to take my attendance. Because there are not so many people here today. Okay, Emma, I'll just say as I you. So you're here. Kayla, you're here. Kayla Harris. Tiana,
Here.
I see you here. Lewis, glad to see you. You haven't been here for a while.
Here, I'm back.
Good. Hope you're feeling okay. We're getting close to the end of the term.
Yeah, I'm feeling better, thank you.
Mariana, no, you're here. Jenna,
I'm here. Good morning.
good morning. I'm glad you're back also.
Thank you.
Sanjita. Good morning. Tahira. We got everybody now. If that's enough time, let's see if we can work on those together. I didn't ask you to graph it, but after we finish that, we're going to try and graph it all. Okay? So first, to find the vertex, we're going to have to figure out what is the A, what is the B, and what is the C. Now, really, for the vertex, you don't need the C, but you may as well write it down. The A in this case is 1, which right in that way means it's an opening up parabola. My B is -10, and my C is 9. So my vertex we get by doing x equals -b over 2a is going to be -10 over 2 times 1, which is going to give us +10 over 2 or 5. To find the y of the vertex, we're going to take this 5 and replace it in the equation, the x by 5. So we're going to do 5 squared minus 10 times 5 plus 9, which is going to give us 25 minus 50 plus 9. Okay. 25 minus 50 is -25. -25 plus 9 is -16. My vertex is the point 5, -13. No, -16. Okay, so that's the first. The y-intercept, and I always do that one first in a parabola because it's easy, is going to be the point x being 0. Put the x, to get the y-intercept, you put the x equal to 0, and of course you're going to get 9, which we know the c value gives us the y-intercept. And if I'm doing a quick sketch of this, here's my vertex is 5 to the right and 16 down. I'm going to go by 2, 4, 6, 8, 10, 12, 14. Here's -16. It's all the way down here. Here's what my vertex looks like. And we said that my y-intercept is going to be all the way up here, 2, 4, 6, 8, 10, someplace here. In other words, this is going to look like this, approximately. I always like to do it's a pretty bad diagram. It's very lopsided. I always like to do a little bit of a sketch after I find the vertex and decide which way it's opening up, because sometimes there are x-intercepts and sometimes they're not. And if this would have been an opening down parabola instead of an opening up, there would have been no x-intercepts. So we just do a sketch so you'll know whether you have to bother finding the x-intercept. But we do. So let's see if we can find the x-intercepts. Looks like there are 2 of them. And we do that by putting, remember, we found the y-intercept when x was equal to 0. We'll find the x-intercept when y equals to 0. So my equation is going to become 0 equals x squared minus 10x plus 9. And the x squared here is positive, so I don't have to move anything. I only moved it to the other side on the other one because I didn't like a negative x squared. It's much harder to work with. And I'm going to try and factor this. Remember, this is the easier factoring because leading coefficient is 1. So this is going to be x and x. The last sign is positive. That means both signs are going to have to be the same. So you look at the middle, they're both going to have to be negative. And I need two numbers that multiply to 9 and add to 10. Well, that has to be 9 and 1. In other words, negative 9 times negative 1 is positive 9. Negative 9 plus negative 1 is negative 10. And then we set each of these equal to 0. X minus 9 equals 0 gives us x equal to 9. And x minus 1 equals to 0 gives us x equal to 1. So basically, finding the x-intercepts of a parabola is just involves solving a quadratic equation. The x-intercepts are 9, 0, and 1, 0. Let's see, 1, 0, and this is all the way 5, 6, 7, 8, 9. There would be your, and notice if you have all those things and a piece of graph paper, you're going to have a pretty good graph. And that's really all you're required. There are other things to know about parabolas, but that's all you're required to know about parabolas. You have to be able to find the vertex. You have to decide whether it opens up or down. And you have to be able to find the x and y intercepts. Okay. So that was the first type of quadratic equation graph we could get from a quadratic equation. What are the other types? So I'm going to erase this and I'm going to go to, we talked about the first type being a parabola. The next type we're going to talk about is something called a circle. So type 1 was a parabola. We know what it looks like. It's either an opening up or an opening down. We should make this go a little bit further out like this. Okay, that's a parabola. The next thing we're going to talk about is a circle. A circle is also a kind of graph you could get when you have a quadratic equation. Now, you know what a circle looks like. The important thing about a circle is two things. You have to know where its center is, and you also have to know what its radius is. The radius is the distance from the center to the edge of the circle. If you know the radius, you could also figure out what the diameter is, because the diameter is going from one side of the circle all the way through the center to the other side, which obviously means it's 2 times the radius. So if you know the diameter, you know the radius. Like if I know the diameter is 10, the radius has to be 5. If I know the radius is 7, the diameter has to be 14. So you have to know what a radius is and what a diameter is. And it turns out that the simplest type of circle you can have on a graph has the equation x squared plus y squared equaling r squared. Now, the first thing you're going to notice is the circle equation is different from the parabola because it has a square by the x and also by the y. Both the x and the y are degree term 2. Now, if we have an equation that looks like this, x squared plus y squared equals 9, this circle this circle that is x squared plus y equals r squared has its center at the origin. And its radius is the square root of this number. This is not, this 9 is r squared, so r would have to be 3. And you don't have to worry about -3 because the radius can't be negative. So the radius of this circle is going to be 3. And the center of the circle, every time you have something that says x squared plus y squared equals a number, it's a circle and its center is at the origin. If I want to draw this circle, what I do is I start on my piece of graph paper, and here's my origin is always right here. I go 3 in every direction from the origin, because the radius is 3 means it's 3 in every direction. So I'll go 3 to the right, 3 up, 3 to the left, and 3 down. These will all give me points on the circle. And then I'll try to draw a circle through those 4 points. Of course, I hope you do a better job of drawing a circle than I do. But this is relatively easy to do. Excuse me. I'm sorry, I'm in the middle of the class, but you see that question? Yeah. Oh, mine's yeah. Not too far. Okay, now I'm gonna call you anyhow because I hadn't put this in better today, but I didn't, I wanted to make sure you certainly are in my house. Yeah. Okay, so when he's ready, I was gonna mention that I am available afternoons, like on Tuesday and Thursday until 3, and so maybe that would be work better. Okay. Okay, bye-bye. Mazel tov, mazel tov. Okay. Now, notice I can give you the equation of the circle and you could draw it. Conversely, I could give you a picture of a circle. Let's say this goes 4 in every direction. And here's what my circle looks like. Okay. I could tell you what the equation of that circle is. That circle, again, has to have an equation that goes x squared plus y squared equals the r squared, because every circle with a center at the origin has this equation, x squared plus y squared equals something. Now, what does it equal? Well, let's see if we can figure out what the radius is. The radius is 1, 2, 3, 4, because we're going 4 in every direction. So that must mean that x squared plus y squared equals 16. So when we have a basic circle, we're going to see that its equation is x squared plus y squared. And that means its center is going to be at the origin, and its radius is going to be whatever this number is here on the other side, the square root. In other words, if this number was 81, my radius would be 9. If this number was 2 might radius be the square root of 2, whatever that works out to be. Doesn't always come out to be a nice even number, but that's the basic circle when its center is at the origin. And of course, one of the questions you're going to ask me is not every circle is going to have its center at the origin. So let's see if we can figure out what the equation of a circle whose center is not at the origin is going to look like. Well, in a circle whose center is not at the origin, we're still going to have an x squared and a y squared. That is mandatory, because if you just had an x and no x squared, or a y and no y squared, you would have a parabola. So you need an x squared and a y squared. It turns out, if you have something that looks like this, x minus 3 squared plus y minus 1 squared equals 25, where you have x with some number inside of parentheses, which means really it's an x squared, but a lot of other things there. And there's a y squared, but of course there's something else there. If it's not just an x squared alone or a y squared alone, but there are other terms, if it's written in this fashion, this is also a circle, and the center of that circle is just the opposite of the numbers that are in the circle, in the parentheses. In other words, the center of the x is going to be 3, and the y center is going to be 1. The radius is going to be the same way we talked about before. This is 25. My radius is going to be the square root of 25, which is 5. So we can have a circle whose radius, whose center is not at the circle, at the origin. Let's see if we could graph that, and then let's see if we can figure out what the general equation would look like and look at some of the examples. Okay, so the first thing we want to do if we wanted to graph this would be to go to the point that's the center, 1, 2, 3 to the right, 1 up. Now, of course, you would want to do this on graph paper. This is where your center is going to be. You're going to want to go 5 in each direction. So you're going to want to go 5 to the right from that point. You'd want to go 5 up. You want to go 5 to the left. And you wanted to go 5 down. And now you have your 4 points that you can again. Hopefully you have a better, your hand is steadier than mine, but that's basically what your graph would, your circle would look like. It now would be centered at the point 3, 1. Again, the radius is always the square root of this number. The general equation for this is x minus a squared plus y minus b squared equals r squared. This is a general equation of a circle that's not centered at the origin. The center of this circle is the point A, B. Notice this was negative minus 3 minus 1. The center was positive 3, 1. It's just the opposite signs. The radius is r, the square root of this number. So it's a little bit more complicated than what we had before, but it's still something that we can work with. So what if I gave you this example? Suppose I told you I had x plus 2 squared plus y minus 3 squared equals 16. I'm going to do this one with you, then I'm going to give you one to try on your own. I see this is in that format for a circle, but a circle whose center is not the origin. It's an x plus something in a parenthesis squared, and a y minus something, a y plus something in a parenthesis squared. In other words, I do have an x squared and I do have a y squared, but I have other things going on. And the number on the other side, we know that's 16, that's going to give us the radius. So in this case, our radius is going to be the square root of 16, which is 4. The center, and here's the important thing, is going to be -2, +3. Notice this doesn't say x minus 2, it says x plus 2. Now, x plus 2 could really be read as x minus -2. So really, the opposite, this should be a -2. So here's the hint. Whatever the sign is in the parentheses, on the center, it's just the opposite. So this is +2, your center, your x value for the center is -2. This is -3, so the y value of your center is +3. It's just the opposite sign. So what if I gave you this equation? Okay. I'll give you a minute to figure out. I think you should realize it is a circle because it has an x squared and a y squared. What is the center of the circle? And what is the radius of the circle? Okay, so let's see if we can figure this out. I'm erasing this because it's just taking up too much space, but we're going to remember that in order to find the center, we look at the number that's next to the x for the x value. This is -1, so my center, my x value is going to be 1. This is +2, so my y value is going to be -2. The center of this circle is the 0.1, -2. And the radius is the number that's the square root of this number, which is 3. And of course, if you know the center and the radius, you can draw the circle. Well, let's do it backwards. What if I tell you that I have a circle whose radius is 7? And let's say the center is the point -2, -1. Okay. Can we write this equation? Remember, the equation is x minus a squared plus y minus b squared equals r squared. So let's do this. We know the a is -2. So this is going to be x plus 2. Remember, it always has to be the opposite sign because we're really doing -2 squared plus y plus 1 squared, and it has to equal 49. So even if the circle is not centered at the origin, we can still draw it, or at least figure out what its center and radius is. And vice versa, if I tell you what the center and the radius of the circle are, you should be able to write its equation. Okay, I want to go one step further on this, before I give you any questions to try on your own. Okay. Suppose I gave you an equation that looks like this: x squared plus y squared plus 6x minus 4y minus 12 equals 0. What if I gave you that equation? And I'm telling you, I recognize this right away. See, an x squared plus a y squared, it's got to be a circle, but it's not set up in my nice very organized fashion. It has everything mixed up, and it doesn't have the x with something in squared in a parentheses, or y plus something with in squared, which is just the standard format that I've been using to figure out the center and the radius of the circle. In order to find it, I have to put it in what we call the standard format. This is a equation of the circle, but it's not in standard format. So the question is, how do we get this to be in the standard format, in this basically factored format, so that we can figure out what the center and the radius are? So here's what we do. We take all the x terms and we put them first. So that means we put the x squared plus the 6x and leave a space. We then put the y terms. So that's y squared minus 4y. And we leave a space. And any plain number that isn't either an x or a y, we bring to the other side of the equation. So this 12 is going to be over here. And we're going to do something that we just learned how to do very recently. We're going to complete the square. What does that mean? I'm first going to work on the x's and complete the square on the x's. Remember how we do that. We know this is, complete square means add another number over here to make this two terms, make it a perfect square trinomial. We want the trinomial to be a perfect square. So what we know is the first term is going to be the x. And the second term, the number is going to be +3. It's always half of the x number. That's going to have to be x plus 3 squared, which means that the number that has to be added over here has to be this 3 squared. 3 times 3 is 9. So just like we did completing a square when we were trying to solve a quadratic equation, we can do the completing the square method here as well. Notice I added 9 over here. I've got to add 9 over here. Okay. Different. I'm going to have to do the same thing with the y's. So this is going to be have the y, the square on the outside, and this is going to be a y, and the number next to the y is going to be half of -4, so it's going to be -2, which means that the number that I have to add over here is -2 times -2, which is +4. I wonder if that's showing up. But if I add 4 on this side, I've got to add 4 on this side as well. So this process of completing the square, I do on the x's, I do it on the y's, and then I see, I add up what I'm left with now. 12 plus 9 is 21, 21 plus 4 is 25. And I've taken this example that was, I knew was a circle, but was not in standard form, and I put it into the standard form, and now I can tell that its center is the point -3, +2, and its radius has to be 5, because the square root of 25 is 5. So if we recognize that what we have is a quadratic, an equation of a circle, because it's going to have just a plain x squared and a plain y squared. It may have other things, but it has an x squared plus a y squared in it, which means it's going to be a circle. Then we're going to have to put it in standard format to figure out what its center and what its radius are going to be. Okay, let's do, I'm going to give you one to try. Okay, suppose this is the example I'm giving you. Suppose I give you that x squared plus y squared plus 2x minus 4y equals 4. Notice we see this x squared plus y squared, but we have this extra x and y. If it would just been x squared plus y squared equals 4 without this, well, that would have been, our center would be at the origin. It's only when there's extra pieces here that it means that the center is not at the origin. So let's see if you can figure out, put this in standard form, and then tell me what is the center and what is the radius. And if anybody gets the answer, they can put it on the chat. Okay. Kiana came up with an answer. Let me give you a extra credit. Well, I think we can start working on it if people are getting answers, Kiana. Certainly, it looks like the center is correct. Let's see if the whole thing is correct. Okay, so we're going to have to put this into standard format. So we're gonna put the x's together. So we're gonna have an x squared and a 2x. And we're gonna put the y's together. We're gonna leave a space. And then we're gonna put the y squared and the minus 4y, leave a space. And we already have this number on the other side, so we just leave it there. And now we wanna complete the square on the x's and on the y's. So for the x's, it's gonna be x. Well, divide this by 2, that gives you 1. It's gonna be x plus 1 squared. And 1 times 1 means I'm gonna have to add 1 over here, which obviously means add 1 over here. Whatever I do to one side, I do on the other side. With the y's, I'm gonna have a y, and this half of this number is -2, so it's gonna be y minus 2 squared. And what I'm gonna have to add is -2 times -2, which is plus 4. I'm gonna have to add 4 to both sides. So this right away gives me x plus 1 squared plus y minus 2 squared equals, that adds up to 9. So my center is the point -1. Remember, you're always doing the opposite sign, +2. And your radius is the square root of this number, which is 3, which was exactly what you got. Thank you. Okay, I think we're going to stop right here now. We're going to continue. There are 2 other types of quadratic graphs. We're going to talk about those on Monday. Don't forget to look for the quiz on chapters 6 and 7 on radicals and quadratic equations. Okay, and we will continue where we left off this on Monday. Remember, next Friday there is no class. It's Black Friday, it's Thanksgiving weekend. And our last class, I'm going to repeat, is December 14th. Have a nice weekend.
You too.
Bye-bye.